Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 3 Calculus. Topic Integrals. Subtopic Evaluation of definite integrals by substitution. Exercise 7.10. Evaluation of definite integrals by substitution. What are the steps to evaluate definite integral of f of x between a to b by method of substitution? The steps are 1. Consider the integrand without limits and substitute y equal to f of x or x equal to g of y to reduce the given integrand to a known form. Piramiba integrand adu limit yaudabida y bu in terms of x the natraga x bu in terms of y does substitute tauraga known form the integrand apiba integrand adu known form id standard form amada puthara u. Integrate the new integrand with respect to the new variable without constant of integration. Anova integrand adu integrate toro anova variable adu da constant of integration yaudana. Ahum subada resubstitute for the new variable and write the answer in terms of the original variable. Anova variable adu hanagi original variable da express toro. Find the values of answers obtained in C at the given limits of integral and find the difference of the values at the upper and the lower limits. But step C the panghiba integral aduda limit sing hapchilo aduga upper limit sinjambagi value na lower limit sinjambagi value gi difference to puto o asumna phangba value aduna definite integral sigi value oigani. Exercise 7.10. Evaluate the integrands in 1 to 8 using substitution. Integrand asigi definite integral sigi value putoksi ahanbada in pyramid se I ne denote torsi put x square plus 1 equal to y. Hanagi x asi y the in terms of y the sense tosi differentiating both sides with respect to x we get twice x. From dy by dx we get dx. This gives x dx equal to half dy. When x is 0, new variable y becomes 1. When x is 1, new variable y becomes 2. Therefore, given definite integrand completely changes to new variable as well as its limit also changes. And half log tokrabadi 1 integral of 1 by y the log of modulus of y which is bounded by square bracket and upper limit put at the top of the right and lower limit put at the bottom of the right. And evaluate log of 2 minus log of 1 which is log 1 is 0 we get log of square root of 2 which is the value of the given definite integral. For 2, we have to evaluate this definite integral. Let I equal to given definite integral and which can be written as sine cos to the power 5 pi is given as cos pi and which is cos square pi whose square is cos power 4 pi. Cos power 4 pi into cos pi is cos power 5. Cos power 5 cos pi or power 5 can be written as this. Put sine of pi equal to x, then whose derivative with respect to x is cos pi equal to dx by d phi. We get cos pi d phi equal to dx. When pi is 0, when original pi is 0, new variable x becomes 0. When pi is pi by 2, new variable x becomes 1. Sine of pi by 2 is 1. Therefore, given definite integral becomes, instead of sine pi we have to put x. Therefore, it becomes root over x and it becomes 1 minus x square whole square. Cos pi d phi completely changes to dx and limit is also 0 to 1. Expanding this and multiplying root over x to each term within the bracket, we get this. We have to apply power rule for integral, and integral of x to the power half is 2 by 3 times of x to the power 3 by 2. Integral of this is we get this, and for this integrate of this we get this 1 0. Evaluate. When x is replaced by 1 we get this, and when x is replaced by 0 we get 0. And evaluating this we get 64/231, which is the value of the given definite integral. For question number 3, evaluate this definite integral. Let I equal to given definite integral, and we have to put x equal to tan theta, whose derivative with respect to x is, we get 1. Tan theta, whose derivative with respect to x is sec square theta, we have to multiply by d theta by dx. That gives dx equal to sec square theta d theta. As well as its limit also change when x is 0. When x is 0, theta should be 0. When x is 1, tan of pi gives 1, that is pi can be pi by 4. Therefore, given definite integral becomes 0 to pi by 4 sine inverse of, which is equal to sine of twice theta sec square theta d theta. Then lastly we be cancelling this 2, we get twice theta sec square theta d theta. Taking out 2 and applying product rule, integration by using the formula for integration by parts. Theta is the first function, sec square theta is the second function. Theta remains unchanged. Integral of sec square theta with respect to d theta is tan theta. And taking out minus 2, we get derivative of theta with respect to theta is 1. Integrand of sec square theta with respect to d theta is tan theta d theta. And putting theta equal to pi by 4 we get this, and theta equal to 0 we get 0, and which is 2, we get integrand of tan theta between 0 to pi by 4, whose value is this, and whose tan theta whose integrand is log of modulus of sec theta, bounded by square bracket, putting pi by 4 in the top of the right and 0 to the bottom of right. We get substitute sec theta equal to pi by 4, we get log of root 2, and sec of 0 is 0, log of 0 is 1. We get pi by 2 minus log 2, which is the value of the given definite integral. For question number 4, let I equal to this, which is written as this. Rewrite and put x plus 2 equal to y square, from which we get dx equal to twice y dy. When x is 0 to y becomes respectively root 2 and 2. Therefore, given definite integral becomes this. Multiplying by y square in its term within the bracket, we get this. Applying power rule, we get y power, for its integral is y power 5 by 5. For y square we get y cube by 3, bounded by square bracket. Using fundamental theorem of integral calculus, we get y is replaced by 2, we get this, and y minus y is replaced by root 2, we get this. Evaluating these two values, we get this, which is the value of the given definite integral. For number 5, we had to evaluate this definite integral by using substitution. Given definite integral can be written as this. Put cos x equal to y, whose derivative with respect to x is minus sine x. For y with respect to x is dy by dx. But lastly, we have to put sine x dx equal to minus dy. When x is 0 or pi by 2 and pi by 2 respectively, y becomes 1 and 0. Therefore, which is completely sends to y, whose integral is 1 by or 1 plus y square with respect to dy, whose integrand is tan inverse of y exactly. When y is resubstituted by 0, we get 0. Tan inverse of 1 is pi by 4. Evaluating, we get pi by 4, which is the value of the given definite integral. For 6, we have to evaluate this definite integral using substitution. The given definite integral denominator is a quadratic. Therefore, we have to completing perfect square term containing x, and which is put in the standard form this, which is exactly equal to integral of 1 by a square minus x square. Applying that rule, we get 1 by twice a. log of x a plus x by a minus x bounded by square bracket, upper limit at the top, lower limit at the bottom. We get this, whose value is 1 by root over 17. X is replaced by 2, we get this value. X is replaced by 0, we get this value. Subtracting these two using log, we get this become this. Now evaluating this, we get 17 plus 3 is 20, and taking out 4 and cancelling, we get this. The denominator rationalization gives this, and lastly we get this number, which is the value of the given definite integral. For question number 7, we have to evaluate this definite integral. Completing perfect square, the term containing x. We get this, and which is equal to, which is in the form, standard form, 1 by x square plus a square. Applying that formula, we get 1 by a. 1 by a is here 2, 10 inverse of x by a. X is here x plus 1, a is 2, and taking out half, we get bounded by square bracket and upper limit at the top and the lower limit at the bottom, which is a symbol whose value is x is replaced by 1, we get 10 inverse 1. X is replaced by minus 1, we get 10 inverse 0. 10 inverse 1 is pi by 4, 10 inverse 0 is 0. Therefore, we get pi by 8, which is the value of the given definite integral. For question number 8, we have this. We have to put twice x equal to y. Its derivative is its derivative gives dx equal to half dy. When x is changed to y, we have to change its limit. When x is 1, 2, y becomes, when x is 1, y is 2. When x is 2, y becomes 4. Limit also change from 2 to 4. And 1 by x, x is what? X is y by 2. X is what? X is y by 2. Its reciprocant is 2 by y. Twice x, x is replaced to y by 2, whose square is this. And for e to the power twice x, we get e to the power y. For dx, we get half dy. Simplifying, we get this, which is in the standard form. This is the derivative of 1 by y is minus 1 by y square. Applying standard result, we get whose integral is 1 by y into e to the power y, bounded by square bracket, putting upper limit at the top and lower limit at the bottom, which is symbol whose value is replace y by 4 minus replace y by 2, we get this. And taking out e square by 4, we get e square by 4 times of e square minus 2, which is the value of the given definite integral. For 9, find the value or choose the correct answer in exercise 9 and 10. The value of the integral this is option A 6, option B 0, option C 3, option D 4. We have to choose the correct one. The given definite integral I becomes this, which can be written as this, and which is equal to this. Put 1 by x square minus 1 equal to y, whose derivative with respect to x gives this, from which we have 1 by x cubed dx equal to minus half dy. Therefore, given definite integral becomes from I to 0. Limit also change. Y becomes, this become y, whose power is 1 by 3. Dx, 1 by x cubed dx is minus half dy. Applying power rule, we get this, which is the integral. Putting y equal to 0 minus y equal to I, we get this. Evaluating, we get 6. From 4 options, we have to choose option A. For number 10, if f of x is integral of t sin t dt from 0 to x, then f dash of x is equal to, f of x is equal to integral of t sin t dt from 0 to x. Therefore, is applying integration by parts, we get this. And evaluating f t is replaced by x, we get this. And t is replaced by 0, we get 0. And again applying here, whose integrand is cos t, whose integrand is sin t, bounded by square bracket, upper limit at the top, lower limit at the bottom, which is the difference of sine of x minus sine of 0. We get this. Therefore, its derivative is sine x, its derivative is cos x. Apply product rule in the second term, we get this. And cancelling cos x, we get x sine x. X sine x, the correct option is B. Thank you for watching my video.